Dear students, to establish the relation between the LCM and HCF, I have taken two numbers 36 and 24. 36 I have named it as T1 and 24 as T2. Now 36 into prime factors is coming like this. 24 common factor it is. HCF is the smallest product of the smallest power. These two smallest power, here it is 3 to the power 1 and here it is 2 square. It's 12. LCM is equal to 3 square into 2 cube, 72. Thus when I have multiplied this T1 into T2, that is 36 into 24, I got 864. Next I have taken LCM and HCF. I have multiplied this 12 into 72, thus I got 864. From these two, what I have concluded is that the product of the LCM and HCF is equal to the product of the two terms. That is T1 into T2 is equal to LCM into HCF. So this is one formula for us. When T1, T2 and LCM is given, you can find out HCF. That is, among these four terms, if any three is given, you can find out the fourth. I am coming to example, that is exercise 1.2, question number 4. Exercise 1.2, question number 4. Given that, question 4, given that HCF is equal to 9, T1 is equal to 306, T2 is equal to 657. According to our previous relation, what we have, LCM into HCF is equal to T1 into T2. This implies LCM is equal to, not given, you are asked to determine. HCF is given 9 is equal to T1 306, T2 657. Therefore LCM is equal to 306 into 657 by 9. This is equal to how much you are getting is 22338. This is your LCM. So this is how we used to find out from this relation. One more question from the same exercise. Is here is 1.2 from question number 1.2. This question number 4 I have helped you to solve already. I have done for you. Question number 5 is done already. Question number 6. Let us see number 6. Question number 6. Explain why. Question 6. This is question number 4. Question number 6. Explain why 7 into 11 into 13 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. Solution. Okay. 7 into 11, 7 into 11 into 13 plus 13. This is equal to 7 into 11 plus 1 into 13. This is equal to 78 into 13. Product of two numbers. This is product of two numbers. Of two numbers or more numbers. Therefore, 7 into 11 into 13 plus 13 is a composite number. Also next one is also 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. This is equal to 7 into 5 is here plus 7 into 6 into 4 into 3 into 2 into 1 plus 5 into 5 is 1. This is equal to is a product of two numbers. Is a product of two numbers. It is a composite number. It's a more than 3. 1 is also there. So it's a composite number. Next, we will discuss when a rational number is terminating and when it is non-terminating. Now a number, suppose 1 by 7, is terminating or not? 1 by 8, 1 by 36, 1 by 2 into 7, 1 by 5 into 2, 1 by or 6 by 5 into 7, 2 by 3 into 5 into 2, etc. I have taken these few examples. 1 by 7, this is 1 by 7, this is not divisible, it is not exactly divisible, and its decimal is also decimal is also non-terminating. It will give you a non-terminating number, decimal number. I will tell you at the very beginning, if the denominator is in the form of 2 to the power m into 2 to the power n, 5 to the power n, where m and n are any positive integers, then this will be having terminator. That means at the denominator, no any other except 2 and 5 is present. If other than 2 and 5 is present at the denominator, then it will be non-terminating. Only 2 and 5. So here 2 is not there, 5 is not there, this is non-terminating. This is 2 cube I can write. This is 2 cube. So 2, this is terminating. This is 9 into 4, 3 into 3 into 2 into 2. So this is 3 is present here, this is non-terminating. This 7 is present here, this is non-terminating. This is terminating. 5 and 2, only 5 and 2 is present here. This is not terminating because 7 is present here. This is not terminating because 3 is present here. Seven by 2 cube into 5 to the power 7. This is terminating because 2 and 5 is only present here. Thus, immediately when you factorize the denominator, and if you find that it is in the form of only 2 and 5, no any other numbers, then that particular number will be terminating. Otherwise, it will be non-terminating. So 3 by 35, 35 by 50, suppose 35 by 50, what it is? 35 by 4 2 into 25, 5 square. So it is terminating, 2 and 5 is present. That's all. Next, has come to the irrational number now. Towards the end, irrational number. So irrational number. Irrational number. All the numbers, all the prime numbers under root over prime numbers, root over prime number 3, 2, 7, 13, etc. Root under root prime numbers, pi, and non-recurring, non-terminating decimals, non-recurring, non-terminating decimals are all what? Irrational numbers. And this number cannot be expressed in A by B form. Now, let us prove that root 5 is an irrational number. 1. Prove that root 5 is an irrational number. Proof. Let A by B is equal to root 5, where A and B are co-primes, co-prime. This implies A is equal to root 5b. This implies A square is equal to 5b square. Therefore, this implies what? Therefore, 5 divides A square. This implies 5 divides A. Let A is equal to 5c. From 1, in place of A, I will substitute the value. A is equal to 5c, in place of A square, 5c whole square is equal to 5b square. This implies 25c square is equal to 5b square. This implies, alright, here you say I have given A square is equal to 5b. Now 5 divides A square, that means 5 divides A also. Let A is equal to 5c. So 5c I am putting here in equation 1. In place of A I am putting 5c whole square is equal to 5b square. This 25b square. This implies 5c square is equal to b square. Therefore b divides. Therefore 5 divides A b square. This implies 5 divides b. What we have seen here is A divides 5. Here you see 5 divides A and 5 divides B. Therefore 5 is common factor of A and B, which contradicts what we have assumed. what we have assumed. Therefore root 5 is an irrational number. Irrational number. Thus we have proved root 5 is equal to irrational number. One more example I want to put here is one more example, example 2. Prove that 3 plus 2 root 5 is irrational number. Let 3 plus 2 root 5 is equal to a by b, where a and b are co-prime. This implies 2 root 5 is equal to a by b minus 3. This is equal to LCM b a minus 3b. This implies root 5 is equal to a minus 3b by 2b. Here this is rational number. Is a rational number, but root 5 is an irrational number. Here this is, but a minus 3b by 2b is rational and root 5 is irrational. This contradict is because of our incorrect assumption. Contradicts is because of our incorrect assumption. Therefore 3 plus 2 root 5 is irrational number. That is all. You will try root 2, root 5, root 3, root 7 by yourself in the same process, same procedure. So this I have concluded here. Chapter 1 is concluded. How you feel it? Please give me your feedback. Next chapter we will see second chapter, that is polynomial.